All right, so you just reviewed the water cycle, and you might be asking at this point, all right, so how is the quantity of water vapor in the air actually measured? Well, just like we measure temperature with a thermometer and air pressure with a barometer, we do have a way of measuring water vapor, but we need to understand a little bit more about it first. Humidity, a term that you've probably heard before, is the measure of the amount of water vapor in the air. Okay? And this is determined heavily by how warm or cold the air is. Warmer air is able to hold more water vapor than what cooler air is able to hold. So we're going to learn a little bit more about that here in a minute. Let's take a look at your Frayer diagram on your lesson note sheet, and I would like you to add the definition into that first box. Humidity is defined as a measure of the amount of water vapor in the air. Go ahead and pause the video so you can add that to your notes. In the second box here, we're going to make some connections. So what does humidity remind you of? What does it feel like? Do you have any experiences with humidity that you can put here in the connections box? I know for me, I often think of the summer days on those really humid afternoons as feeling kind of sticky. So I'm going to add the word sticky into my connections box. To me, the air kind of feels heavy. Oops. And I always get crazy frizzy hair on those humid days. Those are some connections I have. If you have your own connections, add them into that box, or you're welcome to steal mine. And make sure you have at least 2 or 3 connections there. And then here in the third box, we're going to add some antonyms. What's the opposite of humidity? Or what are some good non-examples? To me, the first thing that comes to mind, if it's not humid out, then the air is going to be very dry. So I'm going to add dry in as an antonym. The air to me feels light, not heavy and sticky. Do you have some antonyms or non-examples you could put in? Again, if not, feel free to borrow mine. And in the last box here, we're going to put an illustration that helps us to remember the meaning of that word. For me, it's definitely those crazy frizzy hair days. So I put a picture in here of some crazy humid impacted hair. It's going all over the place. Go ahead and pause the video and add your own illustration for the term humidity. All right, moving on. We're going to take a look at relative humidity. So as meteorologists report the weather, or if you look it up online, they don't talk about the humidity today is 100%. They say the relative humidity, and they give a percentage for that. What they're referring to in this instance is the percentage of water vapor that is actually in the air compared to the maximum amount of water vapor the air can hold at a particular temperature. Because remember, we already said that warm air can hold more water vapor than colder air. So I'm going to use these 2 buckets to explain this a little bit more clearly. The red bucket is going to represent warm air. I have a 5-gallon bucket here, and the blue bucket's going to represent cooler air at 2 gallons. If I were to fill this bucket up to the top with water, okay, or water vapor, we would say that it has a relative humidity of 100%. It can hold 100% and it's filled to the top at 100%. If I poured some water out and it was only filled halfway, what percentage would the relative humidity be then? If you said 50%, you're correct. The bucket can hold 5 gallons, but if it's only half full, it's at 50% of its relative humidity. It's holding half of what it can hold. Same thing with the blue bucket. If I filled it the whole way to the top, it would be at 100% relative humidity, holding 2 gallons. If I lowered that to halfway, it would be holding 50%, half of what it can possibly hold. Notice the difference though. If my warm air is able to hold 5 gallons and my cool air is only able to hold 2 gallons, If I'm at 50% here, that's 2.5 gallons of water. If I'm at 50% here, that's only 1 gallon. So the warmer air is able to hold more water or water vapor because it's warmer. So the relative humidity, even though they're both 50%, is going to feel really different on this warm day than it does here on this cooler day. Continue on the page to find out what tool is used by meteorologists to measure relative humidity.